Hi everyone. So this is another video of how to solve an ODE using an analytical, finally can't pronounce it, analytical techniques. So in this video we're gonna go over solving first order linear ODE. The method that we're gonna use to solve this example is gonna be the integration factor. So from here you can find that this is actually linear, first order, ODE, because you have y prime, nothing can multiply, there's no multiplication of phi next to it, there's no square, y prime square or whatsoever. Same thing for the second y. So this is a linear. And the highest order here is a first order. So this is, as I said, is a first order linear ODE. So the way we solve this such an example, the first order linear ODE, is by introducing a new function. We're gonna call this function to be f of x. So f of x is some function of x. So f of x is some function of x. The cool thing about this function, we want to create such a function that we're going to do a trick in math. So once we say that this function is f of x, we multiply the equation, both sides of the equation, by f of x, which is still valid because if you multiply an equation if you have an equation and you multiply it, the right hand side and the left hand side by the same thing, it's still going to be valid. So f of x times y prime plus b of x y is equal to q of x. So we're going to do the multiplication. After doing the multiplication and the expansion, we get the following thing. So what's special about this function? This function, we want to make such a function that would make the left hand side as a product between the function and the function that we want to find. So we want a function, let's call it f of x, that will transform that once we multiply it by the equation, will transform the left hand side into the following form. So here should be f of x, and here should be f of x. And the right hand side, we don't really care that much about it. So which function we are talking about? Let's just have a thought about this function. Or let's try to solve it and think about it at the same time. So this function, most probably going to be an exponential function, because once we differentiate the exponential function, nothing can happen to it. So it's going to stay the same function, but it will be multiplied by another function. So the first guess is it's going to be e to the power of an integral of q of x dx. But how can we get to such a function without guessing? Like how is, for me, like I don't really love guessing, so how to get to such a function? So we want this function, this and this thing to be equal. So let's equate them together. Because that's what we want the function to be. We want the function to make this into that. So they must do, to make this into that, this means that they must be equal. So let's equate this one with that one. And let's differentiate the left hand side. So by the product rule. And let's say f prime of x times y will be equal to the right hand side of the equation. By comparing terms, this thing will be similar. This thing, let me see if I made a mistake. No, so this thing should be prime in one of them. So this, by comparing terms, this thing will be similar as that thing. So what we did here is the product rule. You differentiate one of them and put the second the same thing, and you differentiate the other one and put the other thing as the same thing. So this is from here to here is the product rule of differentiation. So this thing and that thing, they're the same thing, so we can cancel this one from here, cancel that one from here, and cancel the y, and cancel the y. We get left, and cancel the y and cancel the y. We left out by equation, a differential equation of the derivative of the function will be equal to the function itself than another function. So we are left by some differential equation, but by another differential equation. So if we want to find the function, let's integrate this thing. Let's try to solve this function. So df, the derivative of the function f with respect to x, will be equal to the function f of x times q of x. This one is a separable ODE. And we get that, and we get this following equation, which is separable ODE. We can separate the thing that f in one side and things that only in x in another side, because this is f of x, we can put it that side. This is same thing as dy time dy dx equal to y times something with x, so we can put all the f together and put all the y's together. From the left hand side, we get the natural logarithm of f of x. In the right hand side, we can put it at the same thing because we don't really know unless we are given the function. Lastly, we can find the f of x. We can put plus c, but since we only want to find a function that satisfies that thing, we can put c to be any value. The easiest value most of the time going to be c. So we have to think about the procedure from the beginning. What we were doing in the procedure, we had some linear ODE. That's what we want to make it into another form of, that we want to integrate it, or we want to solve the differential equation. We introduce a new function that will make the right hand side into a product of two functions. And right now we want to find the function, or a function that satisfies this thing. And we find that the function is e to the integral of q of x dx. So this is a function that will make us, well, and will make our life way easier. From here, we can go back into the original problem. The problem of solving y prime plus b of x y is equal to q of x, and by introducing this thing we can solve any differential equation that's in this form. Let's try and have an example. Let's have y prime plus 2 divided by x y is equal to sine of x divided by x squared. From this thing we know which function we want to introduce. We can introduce the function f of x That's gonna be the integral of e to the power of integral of 2 divided by x d of x. And from here, f of x gonna be clearly equal to e the logarithm of x squared, because we can, this is ln of x, and just try to, so step by step, so this is 2e to the power of 2 ln of x, which can be written as e to the ln of x squared by the power of exponentials, which is equal to x squared. Since we have the natural logarithm function and the exponential function, they give us the original value, the original thing, which is going to be x squared. So this we first step is we found that function f of x. The second step into solving linear ODEs is multiplying both sides by the function f of x. So we left by d, so x prime, x squared times y prime plus 2xy will equal to sine of x. That's what happens once we multiply everything by x squared. Then this is a square, this is not prime, this is a square. We can see that the left hand side, this is kind of procedure that's going to happen every time as you can do integration factor. The left hand side is going to be equal to the derivative of x squared times y. If you don't believe me, just differentiate it and you get the left hand side of this thing. The right hand side we left us by sine of x. So by integrating both sides, x squared times y, and the integral of sine of x is going to be negative cosine of x plus c. And we have to put c here because we want to have, while in the finding the function of integration factor, we want to find just a function, but here we want to find the family of functions. So we cannot just put c equal to 0, we just cannot forget the c here because we want to find the family of functions, or the family, if we can find all the families. So last step is by division of x squared. The right hand side will be negative cosine of x plus c divided by x squared. So this is the solution of, and this is how to find the solution using the integration factor of some linear ODE.